All right. Happy New Year. Hope everyone had a great break. Um, Wish we were starting face to face. Miss you guys, but we'll just do the best that we can. Okay. My plan is that I'm going to record um, every lesson this week, so that you can kind of have an understanding about how to go about performing these matrix operations. So Unit 6 is going to be all about matrices. It's not a super long unit. I think it's like a total of 3 weeks. Not too difficult either, so I think this is a good place to start. So today is going to be all about intro to matrices, and yeah, and then we'll get into multiplication this week, which I find multiplication to be one of the more difficult topics. So, but with that, here we go. Okay, so just going to the top here through the blanks, it says a matrix, plural, matrices. Okay, is an array of numbers enclosed in a single set of brackets. The dimensions of a matrix are the number of rows and the number of columns. Sorry, that's columns. C-L-U-M-N-S. Sorry for my handwriting. That it has. Each number in the matrix is called a element. Okay, so that's kind of describing this. Like if you were to look at, we'll go back to these in a second here. Look at these matrices, right? Okay, this right here has 2 rows, 3 columns. So this is what we call a 2 by 3. 2 rows, 3 columns. This matrix right here has 3 rows, 2 columns. So we would call this a 3 by 2. This matrix here has 2 rows, 3 columns. This would be a 2 by 3. And then this matrix right here, again, 2 rows, 3 columns, so 2 by 3. Okay, and so that's how we would determine dimensions. All right. Elements are each individual number in here. So this right here is an element. This 0 is what we would call an element. This -3 is an element. This 3 is an element. So see how 2 by 3, if you were to do 2 times 3, what does that give you? 6. This has 6 elements. This matrix does. 3 by 2, 1, 2, 3, 4, 5, 6. 3 times 2 is 6, right? So the dimensions determine how many elements we have in each matrix. Okay. So today we're going to focus on adding and subtracting and scalar multiplication. So to add and subtract matrices, they must have the same dimensions. Okay, they must have the same dimensions. And the resulting matrix will have the same dimensions. Okay? So to be able to add and subtract, we must have the same dimension matrices. Okay? Add or subtract the corresponding, corresponding entries for each location within the matrices. Okay, so I'm about to go over what those, how that looks like. Okay, so let's look at this first example here. It says m minus n. Sorry, so each matrix is denoted by a capital letter. So K is represented by this matrix, L is represented by this matrix, M by this one, and N by this one. Okay. So it wants me to do m minus n. Okay? And so that is going to look like this. So let's go ahead and let's write out m. So m is -5, 9, 2, 11, -1, 3, minus n, which is 2, 6, negative 31, 22, 10, and 0. Okay, so before I can even perform addition or subtraction, which in this case is subtraction because we see this minus sign here, they have to have the same dimensions. Well, this right here is a 2 by 3, 2 rows, 3 columns. This here is also 2 by 3. So therefore, I can then perform matrix subtraction here. So here's what I'm going to do. Okay, I'm going to take the element that is in the same corresponding spot. So see this negative 5 in this first matrix here and this 2? They're in the same position. Since they're the same dimensions, they're in the same position, right? They're just two different matrices. So in this first position up here in this 2 by 3, I'm going to do negative 5 minus 2. Why am I doing a minus 2 there? Because of this minus sign in between here. So this first entry right here, this first element is negative 5 minus 2. This next element right here, corresponding spots, the 9 and the 6, it's going to be 9 plus 6. And then this 2 and this negative 31 are in the same spot, so we're going to do 2 minus a negative 31. I apologize, guys. That should be a 9 minus 6. Sorry. 9 minus 6. 2 minus, and then that's already a negative 31. So the reason why I put that in parentheses is to make sure you understand negative times negative gives you a positive. Now let's go down to our bottom row here. 11 and 22 are in the same position. So we're going to do 11 minus 22. Negative 1 minus 10. And then 3 minus 0. So again, we just did corresponding positions, right? They're in whatever position they share, you're either adding or subtracting those two elements together. So now to finish this off for our final solution here, we're just going to go ahead and simplify. So negative 5 minus 2, that gives you a negative 7. 9 minus 6, 3. 2 minus a negative 31, so that becomes a plus. So 31 plus 2, 33. 11 minus 22 there, a negative 11. Negative 1 minus 10, a negative 11. And that's okay if elements repeat. 3 minus 0 is 3. And that right there is your final answer. So that is m minus n there. Okay? All right, let's move on to the rest of these now. So we're going to do 1 through 5, so you kind of have an understanding. Now I'm going to go a little bit quicker here, okay? So we're doing L and L. All right? So L and L would look like this. It would be same spots, right? Corresponding spots. So you're going to have 8 plus 8, 10 plus 10, negative 1 minus negative 1, negative 9 minus 9, 4 plus 4, 1 plus 1. Again, because they're both 3 by 2s, we can perform addition or subtraction. In this case, we're doing addition. Okay, in this case, we're doing addition. Again, where did I get this from? Just look at your corresponding positions here, right? 8, L and L are 8 plus 8, 10 plus 10, negative 1 minus 1, negative 9 minus 9, 4 plus 4, 1 plus 1. And now we're going to go ahead and add those together, and that's going to be my final answer. So 8 plus 8 is 16. 10 plus 10 is 20. Negative 1 minus 1 is a negative 2. Negative 9 minus 9 is a negative 18. 4 plus 4 is 8. 1 plus 1 is 2. Okay, so if we look at 2, now we're doing k plus n. So k is a 2 by 3. N is also a 2 by 3, so therefore we can perform addition here. So we're just going to take the corresponding elements in k and add them to the corresponding elements in n. So it's going to look like this. So k plus n is this. It's going to be 0 plus 2, negative 3 plus 6, Three minus 31, 4 plus 22, 1 plus 10, and negative 5 plus 0. Add those together to get our solution matrix here. And so we're left with this. We have a 2. Negative 3 plus 6 is 3. 3 minus 31, negative 28. 4 plus 22, 26. 1 plus 10, 11. Negative 5 plus 0 is a negative 5. All right, 3. So now we're doing multiple matrices here. We were just doing 2. You can also do 3. So n minus m minus k. Okay. So first off, are these all 2 by 3 matrices? They are. So 2 by 3 for n, 2 by 3 for m, 2 by 3 for k. So yes, we can go ahead and perform matrix multiplication. I mean, not multiplication, sorry, subtraction. So it's going to look like this. So we're going to start off with n. So this is n minus m here. So n minus m is going to look like this. Okay, it's going to be 2 minus a negative 5. Remember, order matters, so you got to start with n first, then m, then k. Okay, so we've got 2 minus a negative 5. We've got 6 minus 9. Negative 31 minus 2. Just wonder if I don't have enough room here. Sorry. 22 minus 11. 10 minus a negative 1. And then 0 minus 3. So then that's going to give us 7 minus 3 minus 33, 11, 11, and negative 3. So now what we're going to do now is we're going to take this new matrix, which we created from n minus m, and then subtract k from that. So then now this right here, sorry, I don't have a ton of room here. This right here is going to be n minus m minus k. So here's n minus m, and now we're going to subtract k from it. So we're going to do, so this comes first, so then minus k. So 7 minus 0, negative 3 minus 3, negative 33 minus 3. Oh, and this is and I apologize. So you guys, this is where you got to be careful. I'm even making mistakes myself. Sorry, that's a negative 3 minus a negative 3. This was a negative 3, the second element in K. (11) minus 4, 11 minus 1, and negative 3 minus a negative 5. So you just got to be careful about those double minuses because of subtraction there. Okay, so that subtraction was already in the formula, negative 3 minus, and then this element was a negative 5, the corresponding elements were. So just make sure you're seeing that. And so then your final answer is going to be this. It's going to be 7 minus 0, which is 7. Negative 3 minus negative 3, so that becomes a plus, that's a 0. Negative 33 minus 3 is a negative 36. 11 minus 4 is 7. 11 minus 1, 10. Negative 3 minus 5, negative 3 plus 5, that's a positive 2. And so here's your final answer right there. Okay, so number 4 now, m plus n minus k, all right? So let's go ahead here and let's do m plus n first. Okay, so first off, m is a 2 by 3, and n is also 2 by 3. So we know it works there, and then k, what is k? K is also 2 by 3. So we know we can perform addition and subtraction. Remember, we have to have the same dimensions. Have to have the same dimensions. Okay? So, here we go. So using those corresponding elements from m and n, okay, so negative 5 and 2 share that same spot, so negative 5 plus 2. Okay, the 9 and the 6 share the same spot, so 9 plus 6. And then the 2 and the negative 31 share the same spot. Okay? Alright, so then now we go to the bottom row there and we see, okay, 11 and 22 share the same spot, so 11 plus 22. Negative 1 and 10 share the same spot, so negative 1 plus 10. And then 3 plus 0 all share the same position. So we can go ahead and we can add those together. And now let's go ahead and let's see what I get here for m plus n. So now it's going to give me this. It's going to give me a negative 3, 15, 9 plus 6, 2 minus 31, negative 29. 11 plus 22, 33, negative 1 plus 10, 9, 3 plus 0, 3. So this is your new m plus n right there. All right? So now we're going to take this and we're going to subtract it from k. Okay, so we're going to take this and subtract it from k. So now it's going to look like this. So we're going to take first element here with first element of k. So negative 3 minus 0 15 and the negative 3 are corresponding elements, so then we're going to do 15 minus a negative 3. And then we're going to go negative 29 minus 3. Because they share the same elements, the negative 29 and the 3 do. It's corresponding elements, okay? We then are going to take that 33 and subtract 4 from it, minus 4. Share the same. You guys are going to hear me sound like a broken record. Same thing over and over again, okay? I'm going to get this 9 right here. This 9, I know you can't see it because the camera is not up there, but the 9 shares the same position as the 1. So 9 minus 1. And then this 3 and that negative 5 share the same position. So 3 minus a negative 5. Add those all together, and here's my solution. So negative 3 minus 0 is a negative 3. 15 minus a negative 3. Remember, they become pluses, so 15 plus 18. Negative 29 minus 3 is a negative 32. 33 minus 4, 29. 9 minus 1, not 10, sorry. 9 minus 1 is 8. And then 3 minus a negative 5, remember those become pluses. So 3 plus 5 is 8. And here's so it seems like a lot, but really I don't think it's too bad. You guys hopefully by now are picking this up. Okay? It just can sometimes have a lot of steps. All right. So let's go ahead here and let's look at number 5. So, like we said, every time before I start anything, okay, I need to look at the dimensions. Okay, remember, for me to be able to add and subtract, they all have to be the same dimensions. So n is a 2 by 3, k is a 2 by 3, but here we finally have a problem. That L is a 3 by 2. Remember, to be able to perform addition or subtraction, your dimensions have to be the exact same for every matrix. Okay? So, since you have 2 rows, 3 columns, these first two, yes, you could add those together, but then when you get to L, it's a 3 by 2, which is 3 rows, 2 columns. The dimensions are not the same, and so then this is what we would say. We would say no solution. Dimension mismatch. So that is possible. It is possible, and you'll actually see that when we talk about multiplication as well, whether we can do matrix multiplication or not. So recall, when your dimensions are not the exact same, okay? When your dimensions are not the exact same, you cannot perform addition or subtraction. All right, let's flip over and let's look at the back page of notes, and then we'll be done. All right, so there are 2 types of multiplication for matrices. We're going to look at the simpler type today. Okay, that first type is what we call scalar multiplication, and that second type is what we call matrix multiplication. We'll cover matrix multiplication tomorrow. Okay? For scalar, you take a regular number called a scalar and multiply it to each element of the matrix. So here's an example. Find 2m. So all we're going to do is we're going to put this 2. So it's going like this. We're going to write this 2 out front. and then write matrix M there. And so matrix M is 5. Oh, shoot, before we start this, though, let's do our dimensions again real quick. Okay, let's go. This is a 2 by 3. Oh, shoot, I'm sorry. I apologize. Those are the exact same matrix as we had on the front page. Okay, so we already know our dimensions. My bad. All right, so we've got 2 times. We've got our negative 5, 9, 2, 11, negative 1, 3. So all I'm going to do is I'm going to take this 2 that's on the outside here and multiply it by every element inside here. So my first element in my new matrix here, 2 times negative 5, then 2 times 9, then 2 times 2. So that's my first row there, right? All I did was take this 2 and multiply by the negative 5, 9, and 2. And then down the bottom here, it's going to be the same thing. It's going to be 2 times 11, 2 times negative 1, 2 times 3. And now all I do is just simplify that. So 2 times negative 5 gives you a negative 10. 2 times 9, 18. 2 times 2, 4. 2 times 11, 22. 2 times negative 1, I don't know why I'm writing that with the parentheses again, is a negative 2. And then 2 times 3 is 6. And there you go. So that's scalar multiplication right there. So now we're going to combine adding, subtracting, and scalar multiplication. Okay? So 2L plus L is going to look like this. Okay? 2L plus L is going to look like this. So 2L, so that's going to give you 16 plus 8. 20 plus 10, negative 2 minus 1, negative 18 minus 9, 8 minus, or plus 4, sorry, and then 2 plus 1. Again, these first numbers here is just taking each element in L and multiplying it by 2. Okay, and then adding their corresponding element from that second L. And so now we combine this together, 16 plus 8, that's 24. 20 plus 10, 30, negative 2 minus 1, negative 3, negative 18 minus 9, negative 27, 8 plus 4, 12, 2 plus 1, 3, and there you go. There's your 2L plus L. Okay, 4K minus N. Again, K is a 2 by 3, and N is also a 2 by 3, so we're okay here. We can go ahead and subtract the 2. So let's do this. So let's do 4 times K first. So 4 times K is going to be so go ahead and multiply these all by 4. So this is 4K. So that's going to give you 0, negative 12, 12, 16, 4, negative 20. So there we go. So now we've got 4k minus n here. So let's go ahead, corresponding elements, add those together. So it's going to look like this. So we're going to have now 0 minus 2, negative 12 minus 6. Don't let those elements kind of get tied together here. Sorry, I know it looks crazy. It looks like 0 minus 2 minus 12 minus 6. Remember, they're separate. That's 0 minus 2 here. That's negative 12 minus 6. That's 12 minus a negative 31. $16 minus 22. 4 minus 10. And then negative 20 minus 0. Now bring those together, all those elements together, you get 0 minus 2, so negative 2. Negative 12 minus 6, negative 18. 12 minus 31, so that becomes a plus, so 12 plus 31 is 43. 16 minus 22. Negative 6, 4 minus 10, negative 6, negative 20 minus 0, negative 20. There you go, there's your final solution. That right there is 4k minus n. So this right here, having this 2 on the outside, this is the same thing as saying 2n minus 2m. So 2n equals, you're just putting a okay, and so then that's going to equal this. It's going to be 4, 12, negative 62, 44, 20, 0. To m equals 2 times m matrices, so that's going to be a negative 5, 9, 2, 11, and negative 1, 3. So it's going to look like this. We're going to have negative 10, 18, 4. Yeah, negative 10, 18, 4. See, even like I've checked myself, I feel like sometimes I'm going too fast and I'm making a mistake. 2 times the negative 1, negative 2. 2 times 3 is 6. So now we're going to go ahead and we're going to subtract this. We're going to do 2n. So 4, 12, negative 62, 44, 20, 0, minus, so that's 2n right there, minus 2m, which is negative 10, 18, 4, 22, negative 2, 6. So 4 minus a negative 10. That's going to give you plus, so 14. 12 minus 18, which is a negative 6. Negative 62 minus 4, negative 66. 44 minus 22, so 22. 20 minus a negative 2. Oh shoot, were you guys able to see that whole entire time? Sorry about that. So 20 minus 2 is 18. 0 minus 6, negative 6, and here you go, there's your final answer. All right, 2 more, and then we're done. So 2m plus 3k, so same thing again like we did in the last problem. Okay, first off, let's look at 2m. So again, these are the same dimensions. M and K are the same dimensions. They're both 2 by 3s. You always need to check that before you get going because you don't have to do all this work and then it not work at the end. Okay, so 2m is equal to 2 times this. You got a negative 5 here. 9, 2, 11, negative 1, 3. So multiply those all together. So you get a negative 10, 18, 4, 22, negative 2, 6. What is, now we're going to do 3k. So 3 times k, so k is 0, negative 3, 3, 4, 1, negative 5. So multiply those all together. You're going to get 3 times 0, which is 0. 3 times negative 3, negative 9. 3 times 3, 9. 3 times 4, 12. 3 times 1, 3. 3 times the negative 5. Negative 15. And now let's go ahead and let's add those together. Okay. So we're going to have this. So it's going to look like this. So you're going to have negative 10, 18, 4, 22, minus 2, negative 2, sorry, 6, plus 3k, which is 0, negative 9, 9, 12, 3, negative 15. So now let's just go ahead and add those together. So negative 10 plus 0, negative 10, 18 minus 9 is 9, 4 plus 9, 13, 22 plus 12, 34, negative 2 plus 3, positive 1, 6 minus 15, negative 9. There you go. There's your correct answer. That is 2m plus 3k. Alright, so this one right here is just like saying this. It's like if you distribute this 2 to both parentheses here, it's like I'm asking you to do this. I'm asking you to do 2n minus 2k minus 2m. So first off, let's find all this. So what does 2n equal to? So 2n equals, okay, I'm going to go faster by now. We should be okay with this. We should be able to determine, okay, yeah. 2n, I'm just taking all the elements in n and multiplying by 2. So it's going to be 4, 12, negative 62, 44, 20, 0. Negative 2k equals just taking k and multiplying every element by a negative 2. So you get 0, 6, because negative 3 times negative 2 is a positive 6. 3 times a negative 2, negative 6. Negative 2 times 4, negative 8. Negative 2 times 1, negative 2. Negative 2 times negative 5, 10. And then a negative 2m. Same thing, I'm just taking m and I'm multiplying everything by negative 2. Again, I'm able to do all this subtraction because they all are the same dimensions. If their matrices were not the same dimensions, we would not be able to perform subtraction here between these. So negative 2m, so I'm taking all the elements in m and just multiplying it by a negative 2. So negative 2 times negative 5 is a positive 10. Negative 2 times 9 is a negative 18. Negative 2 times a positive 2, negative 4. Negative 2 times 11, negative 22. Negative 2 times negative 1, positive 2. Negative 2 times 3, negative 6. So now that we have all those, we're just going to go ahead here and we're going to subtract. So the first one I'm going to perform is, let's just do 2n minus 2k. So that's going to look like this. 4, 12, negative 62. $44, 20, 0 minus a negative 2k, which is 0, 6, negative 6. Okay. I'm thinking about this, and I think I didn't make really a mistake. This needs to now be a plus in between. I know this might be a little confusing, but we took this negative and we send it through to all these numbers by taking the original K matrix and multiplying everything by negative 2. I'm not going to use a minus sign for a second time when I've already distributed that minus sign through with the 2 when we multiplied. So that's why this needs to be a plus. So don't confuse yourself there. I know it's a little confusing. And so that's going to give you this. Now you're going to get four plus 0, 4, 12 plus 6, 18, negative 62 minus 6, that's a negative 68, 44 minus 8, 36, 20 minus 2, 18, 0 plus 10, 10. Okay, so that's 2k minus, that's 2n minus 2k. So now we're going to do this. We're going to go 2k, 2n minus 2k, all minus 2n. And so that's going to look like this. You're going to have now you're going to have 4, 18 minus 68, 36, 18, 10. Plus, because remember, I already distributed that negative 2 through. So these signs have already changed. So that needs to be now a plus. What does negative 2m equal to? That's going to be 10, negative 18, negative 4, 10, negative 18, negative 4, negative 22, 2, and negative 6. Yeah, it's a long problem. We're almost done though. Almost done now. So now let's just go ahead and combine corresponding elements here. And so then your final answer is going to be this. What is 4 plus 10? That's 14. 18 minus 18, 0. Negative 68 minus 4, negative 72. 36 plus a negative 22 is going to be 14. 18 plus 2, 20. 10 minus 6, 4. And there you go. That's your final answer right there. So yeah, that is definitely, if you can do something like this, then you are going to be good for the quiz and test for this unit. Okay. All right. So yeah, long video today, but that covers everything. That's multiplication and addition and subtraction. Well, scalar multiplication. Okay. So with that, I will talk to you guys on Wednesday. Thank you.